Okay, inverse trigonometric functions. Right? So yesterday we talked about the unit circle. Last week, Thursday and Friday, you talked about the trig functions, sine, cosine, tangent, cosecant, secant, and cotangent. And today we're going to look at the inverses of trig functions. Well, when have we talked about inverses before? Okay, y equals, we did that with some of the work with y equals. What did we do when we talked about inverses? What does an inverse mean when we're talking about it mathematically? Okay, it's not the opposite, okay? Right, we did it back in chapter 7 when we were working with logarithms and exponential functions, but they are reflections over the line y equals x. So if you remember, whenever we tried to find the inverse of a function, what did we do? Right, we switched x and y and solved for y. And we're going to do that with the trig functions, is that we're going to look at this unit circle basically, and the fact that I know that the cosine of 60 degrees equals 1/2. Well, when we do inverses, if you remember, for inverses, we use that -1, right? And we're going to do that same thing. And we're just going to switch them. So we're going to switch the 1/2 into 60 and use inverse notation instead. So here you can see that we've got inverses here. So if we have the function, if sine of the angle is equal to a, or cosine of the angle equals a, or tangent of the angle equals a, then the inverse sine of a, which is the ratio, equals the angle then. Inverse cosine of the ratio equals the angle. And inverse tangent equals the angle. Now, we're going to be talking at some point, or we have talked about the reciprocal functions, right, with secant, cosecant, and cotangent. Okay? That -1 does not refer to them. Okay? So don't get that confused with the exponent that moves things to the denominator. Okay? When we're talking about inverses, we're switching x and y. Now, the inverses of trigonometric functions are not functions themselves because there are many values of theta for a particular value of a. In other words, our domain for sine and cosine, basically, is all real numbers. But the range for them is limited between -1 and 1. And we'll look at that more today. But if I switch them, okay, then I'm not going to have a function anymore. And so it's kind of like x squared, right? Because x squared fails the horizontal line test, so the inverse is not a function. The same thing with sine and cosine. Now, tangent does, but sine and cosine does not. Right? And we'll look at all of them. Right? So based on the unit circle, angles that measure pi/3 and 5 pi/3 radians have a cosine of 1/2. So do all angles that are coterminal with these angles. Right? So we're going to do inverses. So it says finding inverses. Letter A says find all possible values for the inverse cosine square root of 3/2. Now, it says find all possible values. That means that every time I go around the unit circle or go around the circle to a specific spot, I have a specific number. But the thing is that there's an infinite number of times that could happen, right? Because we have all those coterminal angles. And so we have to take all of those coterminal angles into account, right? So we have a two-step process for doing this. Step 1 is find the values between 0 and 2 pi radians for which inverse cosine is square root of 3/2. So I'll go to my unit circle. And cosine is what? Is it x or y? X. Cosine is x, right? So we need to find when the x values are positive, which would be the right side of the graph, right? Okay, the right side of the unit circle. And we're looking for square root of 3/2. So that would be at here, right? And here. Okay. At those two spots, the x coordinate is positive square root of 3/2. Okay. So that is at pi over 6 and 11 pi over 6. So we have pi over 6 and 11 pi over 6. Now, all of the work we're going to do right now is going to be in radians. Okay? We're not going to use degrees unless it specifically asks you for degrees. Okay? You got that? Whenever we're working with these now, okay, everything we do as far as inverses is working with radians unless they specifically tell you otherwise. Right? So we've got, so my answers here then, for step 1, we have that we have 11 or pi over 6 and 11 pi over 6. Okay. Now it says find the angles that are coterminal with those angles found in step 1. Well, let's think about it then. If I go back here and look at the unit circle, right, if I have this answer at pi over 6 here, okay, for square root of 3 over 2, well, if I go around the circle again to that spot, it still equals square root of 3 over 2, doesn't it? And if I go around it again, it still equals square root of 2, or square root of 3 over 2. Well, how far am I going to get back around to that spot? Okay, but we're talking about radians, so in radians it's going to be 2 pi. So every time I go around, add 2 pi, I end up at that spot, right? Can I do it going the other way? Can I do it going clockwise? Yeah. So every time I hit that spot around the circle, I end up at pi over 6 or square root of 3 over 2. And the same with down here. So what we do is we have to take that into account. So my answer then is going to be pi over 6 plus, I'm going to say 2 pi n. And 11 pi over 6 plus 2 pi n. Right? And then we have to put a conditional statement with it. That means that where, that's a comma, where n is in what? It's a type of number. Whole, natural, integer, real. Okay, not radical. Okay, it's where n is an integer. What are integers? You know what integers are? Negative and positive whole numbers, okay? So every time I go a complete rotation, a complete 2 pi, I end up at that spot. And so by putting n there, that means n could be 26. If I did 2 pi times 26, would I still be in that same spot? Yeah, because that just means I'm going around 26 times, doesn't it? Okay. Okay. So when it says find all possible values, we're talking about you've got to add 2 pi n to your answer because it says it involves every time we stop at that spot on the unit circle. Okay? We're talking about all those coterminal angles. You learned about that the other day, right? Coterminal angles. Okay? They differ by 360 degrees if you're in degrees, or multiples of 360, or they differ by 2 pi if we're in radians. Okay? All right, so let's try this one then. It says, find all possible values of inverse cosine of negative 1/2. So we said cosine is x, right? Okay. So first of all, when is x negative? Is it on the right side of the graph, left side of the graph, top, or, well, if it's x, so is it the right or left? Left, okay? So we want to find out when the x coordinate is negative 1/2. So we find negative 1/2 here, and we find it down here. So my answers are, up here it's at 2 pi over 3. Down here it's at 4 pi over 3. So I will say 2 pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n. And then you have to say where n is an integer. You have to tell them that. because every time I stop at 2 pi over 3, cosine is negative 1/2. Every time I stop at 4 pi over 3, cosine is negative 1/2, whether I'm going clockwise or counterclockwise around the unit circle. Now, we're going to be looking at the functions for the inverse trig also. So because more than one value of theta produces the same output value for a given trigonometric function, it's necessary to restrict the domain of each function in order to define the inverse trigonometric functions. Right? So trigonometric functions with restricted domains are indicated with a capital letter. The domains of sine, cosine, and tangent functions are restricted as follows. Okay? So we're using a capital letter if it's a restricted domain. All right? So the trigonometric functions, all right, restricted. So you notice here's capital letter S, capital letter C, capital letter T for them. Okay? And then they have restricted domains. Theta for sine, theta is between negative pi over 2 and pi over 2. For cosine, it's between 0 and pi. And for tangent, it's between negative pi over 2 and pi over 2. And they have that down here in the chart. And notice that for sine, then, it's the right-hand side of the unit circle. Okay? For cosine, it's the top. For tangent, it's the right-hand side. And we'll talk about that more specifically here in a second. These functions can be used to define the inverse trigonometric functions. For each value of a in the domain of the inverse trig functions, there's only one value of theta. Okay? So we're restricting it so you can only find one answer instead of what did we just do? We found an infinite number of answers, right? Because we kept adding 2 pi in. Now, here's why it's restricted. Down here in the fourth quadrant, sine is negative, and the first quadrant, sine is positive. Okay? If we went from 0 to pi, well, sine's positive in both first and second. Right? We can't, so we couldn't have first and second. It wouldn't include all the values we're looking at. Okay? For cosine, because it's x values are positive there and negative here in the second quadrant. So there it encompasses all of the positive and negative values you could get for cosine. Tangent, positive in the first, negative in the fourth. Okay? So it encompasses all of the positive and negative values you can have. And that's where why the restrictions are there. Okay? Now I'm going to show you something else too so you can kind of see it too. Take out your calculator. All right, we're actually going to do a little bit, show a graph of them for a second. Okay, go to your y equals. And just type in sine of x. Now, make sure your mode is in radians. Okay, so we have sine of x in our y equals, our mode's in radians. Okay, and then hit zoom 7. Here's what the graph of sine looks like. Okay, they call it a sine wave. All right. So what happens? It goes up, comes down, hits a minimum point, comes back up. You know, and it just continues on doing that forever, okay? All right, between negative 1 and 1, right? Because if we look at our y values on the unit circle, the y values, the smallest y value is negative 1, the largest y value is positive 1, okay? And so it just shows, if we took all those points we have, just plot them on here, we get that graph. Okay, that's where the graph comes from. Okay. Now, so if I reflected this over the line y equals x, that means the graph then would go like this, right? Okay. Is that a function? No, it's not a function, so we have to restrict it. So go back to your y equals now, and graph the inverse sine of x. So now we're graphing the inverse sine function. Okay? And then go ahead and graph that. So you're hitting second sine and then x. Okay? If we graph that, all we have is that little part there. Okay? Because if we went any farther than that, it wouldn't be a function anymore. Because the graph would have to turn back this way and go back that way and so on. Okay? And we would no longer have a function. So here's what you've got to do then, is that with our numbers then, that this number down here is negative, oops, I need to make that smaller. So when we're talking about sine and tangent, our number down here at the bottom is negative pi over 2, not 3 pi over 2. Okay? So when we look at our unit circle, we're actually going to be doing some renumbering so that instead of 3 pi over 2 down here, this is going to be negative pi over 2. Okay? And all we're doing is then we're going clockwise. Okay? So if I go clockwise here, how far did I go to get to 11 pi over 6? How far is it from here to here? Negative pi over 6. So this is the same as negative pi over 6. Okay. 7 pi over 4, we went down pi over 4. The same distance is going up to here. So this would be negative pi over 4. And then this would be negative pi over 3. Okay. If we're going clockwise, if we're going this direction. Okay. All right. We have those negative angles. And so when we're doing tangent and sine, the inverses of them, when we're talking about the functions, then we're starting at negative pi over 2 and going around up here to pi over 2. We're just doing that number. So if I was to get inverse sine of negative square root of 3 over 2, my answer would not be 5 pi over 3. It would be negative pi over 3. Okay? And make sure you make that adjustment. Okay? So let's go ahead and look at. So all of our, for inverses, okay, our x values for the inverses have to be between negative 1 and 1 for sine and cosine, and it's all real numbers for tangent. And our y values then, okay, or our angles, have to be under these restrictions. Okay, so let's find some answers here. Letter A says evaluate each inverse trig function. Give your answer in both radians and degrees. There you go. Okay, they want radians and degrees in this case. So we find them on the unit circle, write them both down. Okay. All right, so it says inverse cosine negative square root of 3 over 2. So when it says inverse cosine, that means we're talking about the top half of the unit circle. Okay. From 0 to pi, or 0 to 180 for degrees. So look at your unit circle right now. Where is cosine equal to negative square root of 3 over 2 on that unit circle? The top half of it. Will you put it right here so that this nice young lady can see it too? Thank you. No, better. Come on, Ben. Hang in there, Ben. I almost fallen out of the chair. Okay. All right. So, Derek, where at? Is cosine x or y? Or is it the thing on the one on the outside? It's x, okay? So we're in the top part of the unit circle. And which of them is, where is x negative? Is x negative in the first quadrant or the second? Second, okay? They're both positive in the first, right? Okay, they're all positive. So it's negative in the second. So look for negative square root of 3 over 2 in the second quadrant. Okay? for x. Okay, what's the answer there? What's the radian measure? No, it's not, just not there, huh? Okay. So we're talking about up here, okay? X is the first coordinate here. Okay. All right. It equals square root of 3 over 2 right there, right? Okay. So that means it would be this number in radians and this number in degrees. So and I'm going to show you something, okay? So 150 degrees and 5 pi over 6 is our answer. So we'll say 150 degrees, 5 pi over 6. Okay. Now, I'm going to pause this for a second. Oh, I guess I'll show it to you on here. Okay. Now take out your calculator. All right, and I'm gonna show you an interesting little way to do this. Okay, put in negative square root of 3 divided by 2. Okay. So here's the decimal value for negative square root of 3 over 2. Okay, negative 0.866. Okay. Now if I do the cosine of 5 pi over 6, what should I get? I should get that, shouldn't I? I do. Okay. All right, I can check to make sure my answer is correct, is what I'm showing you. Okay, you can actually use your calculator to check to see if it's right. I could change my mode to degrees. Oops. To degrees, and do the cosine of 150. And we get that same answer.
That's what that means, the radians and degrees.
Yeah. When it says radians, it's talking about radians, like 5 pi over 6. When it says degrees, it's talking about, degrees. Okay? Okay. All right. Inverse sine of 3/2. How about inverse sine? Wait a minute. Let's do one more thing. Okay. So you still got your calculator in hand, Derek? Okay. All right. Do the inverse cosine of negative square root of 3 over 2. What do you think I'm going to get? I'm in degrees right now. What do you think I'm going to get? 150. Okay. If I'm in radians, what do you think I'm going to get? I'm going to get 2.61799. Okay? But if I multiply, what did we learn yesterday? We learned how to convert, right? From radians to degrees. So if I want to convert from radians to degrees, we do. So if I do times 180 divided by pi, that answer I just got was 150 degrees. Okay? So the same spot as. Okay? So 2.617999 is actually the radians that goes with 150 degrees, 5 pi over 6. Okay? All right? Okay. So you can actually, your calculator just told us the answer. Okay? All right. Now, okay. Letter B says inverse sine of 3/2. Try to do that on your calculator. Inverse sine 3 divided by 2. Oh, mine says error. Okay. Look at your unit circle again. Okay. What's the largest, and I know you probably understand this is one thing. What's the largest value of y on the unit circle? 1. Okay. What's 3 halves? What's that equal to? 1.5. That's bigger than 1, isn't it? I can't do the sine or the inverse sine of a number larger than 1. Okay? Here's this rule right here. All right? The value of a for sine and cosine must be between -1 and 1. If it's bigger than 1 or less than -1 for inverse sine and inverse cosine, it's undefined. So this answer is undefined. Okay? There's no solution to that. Okay? But your calculator will actually, if it is defined, your calculator will find it. If it's not defined, it won't. Okay? So do these two down here. Okay? First of all, try to use your unit circle to find them. Okay? And then check your answer with your... So a painter needs to lean a 30-foot ladder against the wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? All right? So we have a ladder is leaning against the wall, right? Okay. And so that's going to make what? A triangle. It's going to make a right triangle. So I've got, here's my ladder, here's my wall, and I have this right triangle then. Okay. Now it tells us that the ladder is 30 feet. Okay. So this is 30. And safety guidelines recommend the distance between the base of the ladder and the wall should be 1/4 the length of the ladder. Okay. So what's 1/4 of 30? Okay. So this horizontal distance here is 7.5 feet. Okay. To the nearest degree, what acute angle should the ladder make with the ground? So we want to find this angle here, theta. So how do I find the angle? (7.5/30), and that'll be the angle? No, that's an idea. Okay. Say that again, Ridge. Cosine of theta equals 7.5/30. And why did you think that, Ridge? Very good. Okay. Cosine is adjacent over hypotenuse, which is the two parts they give us. All right. So we have cosine of theta equals that. All right. So how do I find the angle then? How do I find the angle? No, if I multiply by 30, you can't divide by cosine of theta. Okay. How do I find it? And the key to that is right back here. Okay. We have our functions and our inverses. So if I know the angle, I can just do cosine of the angle and it gives me the ratio, right? But in this case, we don't know the angle, we know the ratio. So if I do the inverse cosine of the ratio, it'll find the angle. So whenever you're trying to find an angle, then we're going to do the inverse of it. So to find theta, I'll do the inverse cosine. So I take out my calculator, clear this, and do inverse cosine of 7.5 divided by 30. And we get 1.318. What's wrong with that answer? It's in radians, okay? You have to be very careful when you're doing these problems that you're in the correct mode also. And so I had changed my mode to radians, forgot to change it back. So whenever you're doing calculations, okay, inverse sine, inverse cosine, sine or cosine, always check to make sure your calculator is in the correct mode, first of all, and then you can find the fact that it's 75.52 degrees, which I'm going to round up to 76. Okay? So theta is approximately 76 degrees. Okay. All right, so you want to do this, or you want me to do it with you? Okay. All right, so we have, if you look at the book, let's see what we got here. That's not it. There we go. Okay. All right, so here's the picture that they're talking about in the book for that problem. So let's, I think that's still the same picture. Yep, it says using, okay. Okay, so it says the unusual rock formation is 1 mile east and 0.75 miles north of the lake. Okay, so here's the lake. All right, so now we're going east. Which way is east? To the right or left? Okay, to the right. So we need to go, all right, you got to check on you, make sure you know. So we're going to go a mile east, right? And then we're going 0.75 miles north. All right, up here. And in what direction should the hikers head from the lake to reach that rock formation? So we're going to go to here then. So we've got 1 mile here, 0.75 miles here, and we want to find that angle. Okay, and so I know Ridge knows what it is, how to figure it out now. Okay, who else knows? Which trig function are we using? Travis? And why are we using tangent? Okay, tangent of our angle equals opposite, 0.75, over the adjacent, which is 1, which that's just 0.75, isn't it? Okay, so to find our angle, we're going to do the inverse tangent of 0.75, right? So if you know the angle, you do sine, cosine, or tangent. If you're trying to find the angle, you do the inverse of sine, cosine, or tangent. So inverse tangent, 0.75. And it says to the nearest degree, so the nearest degree is going to be 37 degrees. Fahrenheit? Not Celsius, that's for sure. That would be cold. No, it wouldn't. That would be really warm. Okay, 37 degrees Fahrenheit's not very hot. 37 degrees Celsius.
Oh my gosh.
That's a good thing to find out, huh? All right.